Okay, my difficult name is Ferdinando Lucchesini. I'm Italian. I'm from the Malaysian subsidiary of Biesse company, which is an Italian company with over 50 years of woodworking machinery knowledge, whose glass and stone division, glass and stone department is the Intermac brand name, which also is not as old as BS, but is also more than 30 years old. And today we're talking about the role of smart glass processing in connection with architectural sustainability. Okay, next slide. We are not architects, as a matter of fact, but with over 30 years of experience in machinery manufacturing for processing glass, we can help to turn ideas into projects. And the chain of knowledge is what we have seen until now. We started with Joseph Lim, who talked about design parameter, who talk about concept on how to build the sustainable buildings, and we move them to Jose, who talk about ideas from the architect point of view, and now we delve into something a little bit more on the works side, on the practical side. We'll hear later on AGC talking about materials. We will talk about machinery. And we can move forward. Sustainable architecture is a concept behind the accomplishment of green buildings, whose main features are to be nature-friendly while caring about the dweller's comfort and being all-round cost-efficient. Driving factors to raise green buildings are energy saving, to avoid polluting the environment, and a better quality of life. These targets are achieved with an extensive use of natural or recyclable materials. And we know that glass is one of them, is a pretty much recyclable material. Helped also by renewable energies like solar and wind power and an efficient water management. Next. Here in this slide, we can see a few examples of green buildings around the world. I'm sure that my colleagues who held the webinar before me are much more competent and much more knowledgeable than me to talk about them. But here we have a few examples. Federal Center South Building in Seattle, which has actually gained a 100% score in the Energy Star as a real net zero energy building. Then we have the Park Royal on Pickering Hotel in Singapore, which is a hotel in a garden concept and is also award winner for the sustainable project design and the use of solar energy system. Then we have the San Francisco Public Utility Commission headquarters in San Francisco, in California, and this one is a real energy saver. Imagine that the full structural glazing that is surrounding the building helps to trim the energy bill by 45%, and the wastewater management alone cuts the water consumption by 60%. Then we have the Bahrain World Trade Center in Manama. It's a pretty unusual application. This one, as a matter of fact, is the first twin skyscrapers in the world with their own wind turbines installed on 3 sky bridges. And the 3 turbines deliver a total of 675 kilowatts of wind power energy. That's a lot of energy. And last one, well, homage to Italy, to my company's homeland, the Bosco Verticale, meaning the vertical forest in Milan, which is a daring urban reforestation project concentrating in 3,000 square meters of surface the trees of a 30,000 square meter forest. With natural oxygen production and CO2 absorption, is contributing to the environment and also to the well-being of the dwellers. And it's considered today one of the most iconic buildings, at least in Europe, if not in the world. And let's move forward and talk about the application of glass in the green buildings. Glass has an important role in the building industry, especially so when we talk about green buildings. The main applications are, we see glass more or less everywhere in a building. Structural facade with double glazing and low E glass, fenestration with double or triple glazing, low E laminated glass. Triple glazing is something that is more common in Europe, but it will come. Skylights, obviously all laminated glass, balustrade and railing also with tempered laminated glass or simply laminated glass without tempering, and the photovoltaic solar panels, which is made with a kind of special kind of glass. It's called the ultra clear low iron glass. More importantly, these are the benefits of the value added glass that we mentioned. A wider glass surface for a natural ambient lighting, a high performance facade for better heat and sound insulation, the glass roofing, again for natural lighting, safe covering and power saving, the balustrade for a protected but transparent view, and the PV solar panels, which are, as a matter of fact, energy generators. Next one, the demand from, moving a little bit slowly, okay, in pursuit of the best. What does it mean? It means, seen from the perspective of the builder, what does a builder expect from his glass supplier? These are the 4 key expectations. The quality, which means accuracy, repeatability, flawless production. The punctuality with automation, cutting idle times and fulfilling scheduled plans. Customization, thanks to flexible machines capable of working on small batches and on-the-spot samples without affecting the productivity, and obviously a competitive price, which is always welcome, coming from an efficient production, which is a saving time, material, and so money. These points are all driving towards one direction: process automation, the best practice to grant a perfect all-around service to the builders. Next one. And what are the features that make a factory a smart manufacturing hub? These are the 6 points. The machines are no more standalone items, but they form an integrated, seamless flow of production. They exchange data and communicate to each other. There is a supervisor which controls productivity, quality, efficiency, and provides statistics. And supervisor is not meaning a man, it's meaning a software. Machines are online, performance and status can be remotely checked at any given time. The processing flow is the fastest with the least human intervention, and machines are equipped with predictive maintenance software for a hassle-free and reliable operation. Next. So we talk about this value-added glass, like insulated glass unit, like laminated glass, like tempered glass, but all these high-value glasses, to produce them, it all starts from the pre-processing. And this is Intermac focus and know-how. With our range of handling and loading systems, float and laminated glass cutting, seaming, edging, polishing, working centers, water jets, and washing machines. Giving the right importance to the whole processing cycle is what makes a glazing business successful, and Intermac is here to help each customer to do so. Next one, and we will go step by step through the processing line. First task when the glass arrive in the factory is to unload them. They are large blocks, they are weighing some tons, they are hauled around and stored for future use manually. Manually handling glass of such weight and size is difficult, dangerous, and time-consuming, and can even result in costly mishaps. Glass, let's not forget, is a fragile, is an easily breakable material. Minimizing this operation saves time, money, and staff precious health. The solution lies in the range of automatic stock selection systems by Movetor, from manual handling to Movetor solutions. Movetor is a company of the Biesse group and has the widest range of storing and handling machine fitting the space, production, and budget that each customer may have. The main benefits of this solution are all the stock can be readily available for cutting. No more double handling of the glass packs or sheets with all the related risk factor, and this is particularly appreciated by customers. The possibility to restore and reuse the half plates that haven't been fully used, and the modular concept of the solutions, which allow the stock area to grow in the future with the growth of the company and the production increase. Next one, we will have a look at the different, if not all of them, but some of the most common solutions provided by Movetor. These are called telescopic loaders. They are single sheets mover. It's meaning that they pick up one sheet at a time. They are a compact solution. As you can see, there is a certain set in the back of the picture of different kind of glass that can be picked up. They are all available for pickup. There is an arm, which is sliding inside the stock with suction cups. It's picking up one sheet at a time, tilting it down and sending it to the cutting table. It's a flexible production because every second sheet can be different from the previous one, but nevertheless, it's a productive one. It delivers up to 150 sheets in one shift. It can feed one or two lines according to what is the size of the lines and what kind of production they do. It can be easily expanded, and it has as options also the possibility to manage the half sheet, to return the half sheet to the stock, and even move glass from one rack to the other. Next one. We still stay in the single sheet movers, but you can see that this machine looks pretty big compared to the previous one. You can see that the stock is much wider. These are called gantry loaders. These gantry loaders, they are able to deliver up to 200 sheets. In terms of stock, we may say the sky is the limit, because we have customers who have made stock with 100 and even 150 positions, 150 different kind of glass stored in their factory. We have examples in US, in South America, in Europe. They can feed obviously multiple cutting lines. They have an interesting pass-through cycle to handle the low E, soft-coated low E glass, which brings us back to the green building theme, because the soft-coated low E glass is one of the glasses with the best U factor, and this is meaning that it's a very good for insulating inside from outside. It can have the track of floating. I will explain to you later what it is when we talk about the next one. And again, remnant management and rack-to-rack are also a given in this solution here. Next one is a different concept. Next slide, talk about pack movers. What is the difference between the previous ones and this? The fact that the glass is not anymore managed one sheet at a time, but one pack of glass at a time. It's meaning that this machine that we see in the middle of the picture, the one that is running on rails, like a small train, is actually capable of loading a rack with a pack of glass on top and delivering that to a cutting line. The productivity is the highest. We're talking about up to 300 sheets in a shift for each cutting line that is feeding. Just to give an idea, to not everyone is familiar with the ratio between sheets and size, we're talking about over 5,000 square meters of glass to be cut in a sheet. In a shift, sorry. It feeds multiple cutting lines. It has a maximum payload per square meter, and again, remnant management, rack to rack, and the capability, which is a feature exclusive to this solution, of refilling the stock as it works without having to stop the line for the simple reason that the refilling, when the truck is coming from outside and delivering a pack of glass, this pack of glass is loaded outside the fenced area, the safety area where the machine is working, and it will go and pick it up and send it to its position when it's done with the other mission. So it can work 100% of its time without any single interruption by refilling the stock in total safety. So we can say in a nutshell, Movetra has a tailor-made solution for each and every production needs. Next slide. Okay, from loading to cutting. The next step is to cut the glass. We have a big sheet of glass. It has to be cut into pieces that will soon be processed, transformed in high value glass, in added value glass, which will go into the green building. So as a matter of fact, the cutting table is nothing new on the market. Cutting table has been around for decades. But the Intermac cutting tables, they offer some exclusive and patented feature like the automatic cutting wheel selection for the perfect score in any condition, straight cut, shape cut, thin glass, thick glass, without having to replace them manually, which is a loss of production. And today they are actually really multifunctional machine, because we can see in the other picture two other functions which are important specifically for our talk about green building, and not only. The edge delation of soft-coated low-E glass for IGU. Edge delation is something that is required in order to remove a coating, which improves the U value of the glass. But at the same time, if you don't remove it, it wouldn't allow to make a IG unit which stays together, which sticks together for 10 or 20 or 30 years. That is the expected lifetime of an IGU. So in order to do that, you need to remove this coating, this metal coating that there is on the surface of the glass, and this is the right way to do it. Then we have the glass leveling. Glass leveling doesn't refer necessarily only to the green building, but it refers to the better, or I would say the best practice of production. Because if you can level each piece while you're cutting it, this will be a piece that can be tracked down through all the production line of the glacier, and can even supply some useful information later on to the customer. It has a QR code, can be printed with a QR code, which is not only important to know what glass is that, but even to automatically tell the next machine what they have to do. It carries all the information to adjust the other machines without having the operator to do that. What does it mean? Less mistakes, less wasted glass, less production time increase because of errors. Next one, I would like to focus a little bit on the laminated glass for a simple reason. The laminated glass is one of the best examples of safety glass, and there is definitely quite a certain amount of laminated glass around buildings. Specifically in a building, we can see some examples, some pictures. There is laminated glass, obviously, in the skylights. There is laminated glass for the same obvious reason also on balustrade. The balustrade must be something that if a kid with a tricycle hits the glass, it doesn't allow him to fall off, for a simple reason that the laminated glass stays together. It doesn't crack and falls like tempered glass, but it stays together. Staircases, railing, balustrades, balconies, glass flooring, curtain walls. There's so many examples of laminated in a building. So Lamiglass, I don't need to explain probably anybody how a laminated glass is done, but in reality, as we can see in the picture, it's made of 2 or more, even 3, 4, depending on the level of security you want to have from the laminated glass. 2, 3, 4 layers of glass interleaved with some plastic, transparent plastic, typically it's called PVB, but there are other solutions too, which allow the glass to stick together when it gets broken. So it's good for safety, it's good for security, but not only. Another main feature of the laminated glass is that it is a sound dampener. The plastic inside acts as a dampener of the sound, so it's good for insulation from the outer noise inside the building. And it's also, last but not least, good for the UV rays. Okay, so now from material to how to process this material. In Southeast Asia, we have to say that the use of laminated glass is not as big as in other parts of the world, or at least there is laminated glass, but it's not processed so frequently as it is, for example, in Europe, for a simple reason, that there is not yet a huge demand of laminated glass. In Europe, just to give you an idea, IGUs are, we would say, almost completely, for new buildings, we're talking, almost completely made with laminated glass, 2 panes of laminated glass instead of 2 panes of float glass. So this is meaning that there is a massive demand of laminated glass. The proportion between laminated and float glass is 80 to 20. Most likely here in Asia, especially in South, the proportion is the opposite. It's 80% float, 20% laminated, if we are lucky. But it's coming. I can tell you that it's coming. How does it work in Europe? In Europe, the laminated glass is manufactured, not custom laminated, piece by piece, glued together piece by piece, with a lot of time wasted, with a lot of energy wasted in the autoclave, because you are producing small panels instead of big sheets. In Europe, it's produced by sheets, jumbo, regular sheets that are cut to size by machines like the one that we see in this slide. Machines which are capable of scoring the 2 sides of the glass at the same time to create an automatic cycle, so that the 2 sides of the glass are not only scored, but they are also open. There is also the breakout. Then there is a PVB heating, melting, and then the separation of the 2 pieces, which is granting a productivity and allowing the glazier to complete orders of lami glass, not in days, but in hours, starting from the big sheet. The range, as you can see, there are 3 examples. The range is from the basic machine, the standalone machine, single table, which is suitable for a customer who wants to delve into this kind of technology with a reasonable budget, to the more technological cutting line, the one in the middle, which has added features like plate and sheet rotation, automatic piece alignment, and the innovative, which is something, a breakthrough, cutting shape cycle for laminated glass. Until recently, the laminated glass by machines could only be cut with the straight lines, not in shape. Now it's possible also to do shaped cuts on laminated glass. If you want to do a domed window, you can do it. Finally, space saving, you got the combi line. The combi line is a combination of 2 different technologies, cutting float glass and cutting laminated glass in the space that the line in the middle is taking. So practically it's a very space efficient solution for customers who want to be able to cut laminated and float glass. Again, the combi line is still more popular in Europe than any other place in the world. Again, for the simple reason that is cut 80 to 20, the proportion. Okay, we can move forward and talk to what comes next. The automation is a trend that is becoming important in all the phases of the glass factory. After cutting the glass, an edge must be processed with different level of finish according to the application and the kind of value-added glass that is going to be used in. Laminated glass will require a different level compared to IGUs, and tempered glass, depending if it is framed or not, will require different edge work. Our CNC can work pieces in shape or can process additional jobs like drilling holes in the glass, making cutouts, for example, for making doors where there is holes for the handles, or what they call in in a common language of the glass, the Mickey Mouse for the hinges and so on, or they can also make some other particular, peculiar processing like the surface engraving, the face of the glass engraving for decorative purpose, or also beveling of the edge still for decorative purpose. All of these can be done with the CNC working centers of Intermac, which actually in this field is really considered a market leader. Intermac was the first company in the world who invented the CNC working center for glass processing. So we are still the market leader, and we are innovator because we are studying new solution every day. The robotic cells, that's where we come about to the title. The robotic cells are making the automation into this machinery. A single robot can serve 1 or 2 machines, and the deployment of a robot can grant a long list of benefits compared to the manual loading, which is 90% of the way customers are loading the glass into their CNCs. And the benefits are reducing the operating costs, improving the product quality and consistency, raising obviously the daily output because the robot can work 16 hours without interruption, saving factory space, complying with safety regulations, and avoiding, also important, the human factor errors. Okay, having talked about the process, we may give an example with the next slide of a layout of factory integration. Example of factory integration. In this example, which is not simply something which is on the paper, we have all the machines which become a seamless solution from machines to solution, allowing a smooth flow of the glass pieces, satisfying the targets that were declared by the company owner, which were 2 simple words: only in line and no more glass touched. He expressed this wish, Intermac delivered. Right to left, we have a Movetro shuttle system with 70 stock positions, 70 jumbo stock positions, 2 cutting lines, 1 above and 1 below, both for monolithic and laminated glass, so they are flexible and they can both cut both kind of glass. There is a conveyor on the bottom, the gray one, 15, 10, 12, you see that point. This conveyor is delivering the glass to 2 robots, which in turn, according to the kind of job, pick and load the piece and send it either to a horizontal working center or to a double-edger, the number 16, which is polishing, grinding and polishing all 4 sides of a square glass in one single fast cycle. The other cutting line, the upper one, is number 5, is delivering the glass to a very flexible vertical working center, which is number 6 and 7. 7 is actually the loader, its own loader, which is giving the maximum automation, but a lot of flexibility. This is the remarkable display of technology that we are going to see in the next and final slide, where we will see the clip of this customer who is called Toulard de Ver, and it's a French customer who has entrusted the Intermac to his full glass operation. This is Mr. Glumineau, the CEO of the company. Sorry, the whole video is shot in French because they speak French, but it is showing pretty much is a subtitle in English for you to see and understand. This was the area of the stock. He said that in 2008, they wanted to realize this fully automatic line. Here we can see not 1, but the 2 robots. They are dealing with different kind of production. They are dealing with decorative items. They are dealing with architects who require special, colorful pieces of glass with nice motifs, which are made through a silk printing machine, a digital printing machine, which is turning glass into art, like these examples here. These are all panels of glass printed digitally by a machine that they have. And all these final products for architectural purposes, they were done through this input. Nothing touched by a man, and every machine in line with the other. Here we can see the robot picking up glass and delivering to the CNC, to the horizontal CNC. This is Mr. Piscina, who is the managing director of the company, and he was the one who directly dealt with Movetro and with Intermac to create this solution. This is the shuttle which is carrying the glass to, you see, this is a panel of 6 by 3 meter of glass laminated, which is going through the laminate cutting machine, a very automatic machine which can deliver pieces, as I said, in hours, not in days. The challenge was not to touch the glass, and the challenge was to have a full control of the production. And we managed to achieve both of them by means of a solution which has been put down in more or less 1 year from the very day we started the project to the delivery of the full system fully working. No more, as you have seen before, what they didn't want is to have a man carrying around a big sheet of glass around, hanging from a clamp, dangerous, difficult to move around, risk of hitting anywhere, breaking the glass, hurting somebody. All of them is a history for TEV because they managed to get all this system fully automated, fully functional. Now, we will see that this is not only automation, but it is also very space efficient. If you have seen the layout, there was practically no space wasted around the machine because there is nobody who has to walk around the machine doing some work. The machine can be as close as possible and need to be as close as possible to save on factory space, which doesn't come free, and at the same time allow to bring in an ordered flow the final pieces that we see here already on the rack to be sent on the market. And this is just them saying that with the cooperation with us, we managed to make this kind of dream come true. This comes to the end of my presentation. I thank you all for the attention, and I pass back the word to Sarah. Thank you.
Thank you, Mr. Ferdinando, for the wonderful presentation. Thanks for showing us how it is possible to fully automate manufacturing, and that will enable us to work hand in hand with designers and contractors to reduce wastage and improve efficiency.